Hello and welcome to this guide where I will be walking you through how you can bring your own model into the Infineon ecosystem using the DEEPCRAFT Model Converter. Now, whether you've developed your model on your own and just want to bring it down onto the board, or you want to leverage some of the online tools and models that are already available, the DEEPCRAFT Model Converter is the tool that you can use in order to generate optimized C code that you can easily deploy onto the Infineon microcontrollers. In this video, I'll showcase the features that are available and how you can go about doing that. So this here is the software, which you can download through the Infineon Developer Center, and you can select your target devices. Now, this supports currently the PSoC 6 as well as the PSoC Edge, and that includes both cores, the M33 with the NN Lite being the proprietary Infineon neural network accelerator, and the PSoC Edge, the M55 core with the Ethos U55 accelerator. So you can select any of these devices and it'll automatically generate code that runs on those devices. The input models that you can select are, for example, the TensorFlow Keras, a .h5 file, TensorFlow Lite, .tflite file, and even PyTorch models for .pt2 files. And you can select what input model you want. Now for this example, I have a model that I've just downloaded from an online source, the ResNet model. So navigating to the ResNet model and selecting the H5 file. You can select where you want the actual output to be. The input model shape will be automatically populated. However, for PyTorch models, they will have to be entered in manually. And then you can select the API prefixes and model names. The default ones will do you well in order to actually work with the rest of the code examples we have available. For specifically the PyTorch models, there's also the option to enable local conversion instead. We also support the quantization of models into int8. If you select this box here, you can select a number of different data formats that will be used as the reference data for the quantization. And I will, for this example, select a .npz file, which has both outputs and inputs of the data. There's also an option available to enable sparsity if you want. For specifically the hardware accelerator, there are some options for the Ethos U. These ones are for the users that are more well-versed in the firmware. If you want to, for example, change how much arena cache you have, if you want to optimize for performance or for size specifically, or want to dictate how you're actually allocating the memory mode. These are options that you can play around with here. There's also an option for validation, where you will be able to get results and see how well your model actually performs on device. If you have selected to do quantization, you will also get a report on how your model has changed in quality from the quantization. So by enabling this, you can select a data file as well. In this case, I will use the same data file as I'm quantizing with, which will have some mild degradation of the believability of the results, but it still is functional. For the best machine learning practice, you should actually have a completely separate file. And now, I'm ready to just begin the training of the model. I can define where I actually want to create this project. I have a folder called Model Converter, and I can start the code generation of this model. And once the code generation is complete, you will get a pop-up telling you to open that directory. There is also an output at the bottom where you can go and view some of the more details on the validation results and the quantization. But there is a summary of all of this in a code generation report, which is in a markdown file that you can open. Let's just get some better preview of this. And you can have a view of what the model needs and requires for memory, both for the actual model and for the scratch memory. And because this was using the NPU, you get a result given in how many cycles are needed to run the model, as well as detailed results on the actual validation metrics of the model for you to go through. And the code files that are generated is a .c and a .h file, and we can open these up. And these are simply optimized C code, which have a small number of functions that you can call upon and actually implement into your application. And this you can do, for example, through Modus Toolbox. And there's also an additional link you can click on to further guide you on what to do with the generated code and how to implement it into your application in Modo's toolbox. But that is it for this video. Hopefully this was helpful in order to bring your own model into the Infineon ecosystem. Thank you so much for watching.